Hi there everyone, this is your lesson for 8.4. 8.4 really is just going to take SOHCAHTOA and kick it up just a tiny little bit by bringing up some real-world problems. These real-world problems are going to feature two types of angles, and those will be called your angles of elevation and your angle of depression. Angle of depression always causes issues with students, so let's make sure we really lock this down today. I will enable your Math Excel, but this will not be due until Monday. And remember, the following Tuesday, so Tuesday the 30th, we are taking our Chapter 8 test. Let's get started. What are the angles of elevation and the angle of depression? Both angles of elevation and depression are created by horizontal lines. I'm going to emphasize this piece right here because this is the piece that is most commonly missed. I want you to think about your eyes. So if I draw a little eye right here, it's not my best eye I've ever seen. But when you look, you always look typically straight in front of you, which creates a horizontal line. Now, depending upon where something is located, you will typically tilt your eye up or you will tilt your eye down, okay? These are the two types of tilts, the two types of angles that we are talking about today. The angle of elevation will, of course, be when you tilt your eye up, okay? So this will be, in this example right here, this right here. Notice the angle of elevation is formed by a horizontal line, and this girl's eyes look up. The angle of depression would be this angle right here. Notice it is formed by a horizontal line, and the person that is up in this little plane-like object looks down on the person, and that is your angle of depression. I'm going to show you the common mistake. Common mistake for angle of depression. People believe that this is the angle of depression. However, it is not the angle of depression because notice it is created by a vertical line. That does not adhere to the definition that the angle of depression is formed by a horizontal line. Our first example today does not really require much math. It just requires us to identify the different angles that we're looking at here. So we're going to identify together angle 1 and 4, and you're going to take care of angle 2 and 3. And we're going to fill in the blanks to help us describe the situation shown. Angle 1. I'm noticing that here is the horizontal line creating angle 1. And to create angle 1, I would create a downward direction. Because it's going downward, angle 1 is going to be classified as an angle of depression. Now I want to get specific. This angle of depression is the angle of depression going from the bird to the person in the hot air balloon. So it goes from the bird to the person. Now we're going to look at angle 4. I notice that angle 4 is created by this horizontal line, and it's an angle that would be created by going up. Because it's going up, angle 4 is classified as an angle of elevation. Alright, so I'm noticing that angle 4 it's kind of like the base of the mountain or the ground, and it goes up to, once again, the person. It is now your turn. Take a moment here to classify angle 2 and angle 3, filling in the blanks like we basically would have done for angle 1 and angle 4. Let's check your answers. So, angle 2 is an angle of elevation. It goes from the person in the hot air balloon to the bird. Angle 3 will be an angle of depression. It goes from the hot air balloon person to the base of the mountain. So something I want you to recognize. Remember, both of these angles are created by horizontal lines. Well, something we know about horizontal lines is that horizontal lines are parallel to one another. So this line of sight going from these two people, this acts as your transversal, okay? So I want you to recognize that actually your angle of depression, your angle of elevation are alternate interior angles. And because they are alternate interior angles and they are created by a pair of parallel lines, by the alternate interior angles theorem, the angles are congruent to one another. So when you are creating the diagrams for our problems coming up, just recognize that you can always simply put the angle of depression where the angle of elevation is located. I only got 2 more problems for us today. Here's the first one. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is this turbine from the ground to its hub? So here's what I'm trying to find. But something else I need to take into consideration is the height of my eye level. Okay, so that would be this distance right here. This is a distance of 5.5 feet. Well, that also carries to over here. And I'll need to take that into consideration at the end, okay? So let's take a look at this right triangle that creates a situation. I have my angle of elevation, once again created by a horizontal line. And I have recognized that the distance from my eyeball to this turbine right here is 53 feet because that's how far apart I'm standing from the turbine. And what I'm trying to find is this chunk of the height. So the first thing I always recommend that you do in this particular unit is write down on the top of your paper, SOHCAHTOA. And when you write down SOHCAHTOA, it helps you recognize which one are you going to use. Notice in this particular problem, I have nothing to do with the hypotenuse. And because I have nothing to do with the hypotenuse, this is going to be a TOA problem, okay? So now I need to create my tangent equation. All right, so we have tangent of some angle is equal to an opposite over an adjacent. Well, the angle at hand in this particular problem is going to be my 56.5 degrees, okay? Because this is my angle of elevation. So then, opposite of 56.5 degrees is going to be x. Adjacent to the 56.5 degree angle will be 53. And now, all I need to do is solve for x. So I do that by multiplying 53 onto the other side. So we really have 53 times tangent of 56.5 degrees. That is equal to x, okay? Now, this is once again, my reminder to you, you gotta be in degree mode. If you're not in degree mode, you are not gonna get these questions right in your checks. So make sure you're in the right mode here. So when I type in 53 times tangent of 56.5, that gets me 80.07 approximately. Now I gotta remind you, we're not done yet because I want to know the entire height of the turbine. So I gotta take into consideration that little chunk down here of 5.5 feet, and I'm gonna take care of that by adding it on to the height that I've already found. So therefore, what I get approximately is 85.57 feet. And it just says approximately, so I can leave my answer like this. If it said round to the nearest tenth, I would have an answer of 85.6 feet. It is now your turn, and you can notice that you actually have a diagram already drawn for you. The only other piece that I need you to recognize is you do have a distance for your eye level. So you do want to recognize that this length right here is 6 feet, which is also going to carry over to this length right here. Take a moment to solve this problem. All right, so maybe you're noticing tangent is a well-liked concept with angle of elevation and angle of depression. With most real-world problems, you do use tangent, but I'm saying most, so don't get in the habit of always using it, okay? Hopefully you set up your tangent ratio and you got approximately 625 feet, but then you remember to add on that 6 feet, getting you an ultimate answer of 631. Let's take care of the very last problem of Chapter 8. I'm certainly going to miss this chapter for sure. All right, to approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent, okay? So this is going to be my angle of depression, okay? Here is the horizontal line creating this angle of depression, and here I am looking down. Therefore, that is my 3-degree angle, okay? It is starting at a height of 2,714 feet above sea level, and the airport is also significantly above sea level. So I'm going to draw this right here, recognizing the sea level piece, okay? And even though sea level doesn't mean this is how far I am exactly above a sea, because Obviously, an airport's formed by the ground. It's just the concept here. So this length for the airplane is 2,714, and this length for the airport is 1,007. Okay? I ultimately want to know how far away the airplane is to get to that runway. Okay? So I want to know how far this airplane is going to travel to get to the runway, and that is why in this situation, I'm actually going to solve for that length right here. Okay? So the triangle that I'm dealing with is this piece right here. So you'll notice I'm actually solving for the hypotenuse. So if I actually zoom in right here, here is my x, here was my line of sight, which is 3 degrees, okay? I now also need to recognize I do have more information. I can actually figure out what this length is right here, because this entire length is 2,714, and this little length is 1,007. So if I subtract, 2,714 and 1,007, I can isolate this tiny piece right here. And this tiny piece is a height of 1,707. I'm going to label that on my diagram. All right, so there's actually two ways of approaching this problem here. I can recognize that my 3 degrees is also going to be right here because angle of depression and angle of elevation are the same. Or I can recognize that this creates a right angle, so this is also going to be a measure of 87 degrees. So which angle you use is really up to you. So you could use cosine or you could use sine. I'm going to proceed with the concept that 3 degrees is in 2 locations by the property of alternate interior angles theorem. And I'm going to create a relationship with my angle, this side, and the hypotenuse. So if I think to myself, so, ka, toa, I ask 3 degrees. 1707 is across from 3 degrees, which means it's opposite. And if I have an opposite and I'm solving for a hypotenuse, that is a sine relationship. So we create sine of 3 degrees is equal to the opposite, which is 1707, divided by the hypotenuse, which is x. All right, my variable is in the denominator. So in this situation, I need to multiply both sides by x. So now I have x times sine of 3 degrees is equal to 1707. I then need to divide both sides by sine of 3 degrees. So divide by sine of 3 degrees. And that will cancel this out on this side, getting me x is 1707 divided by sine of 3 degrees. Remember, you need to be in degree mode on your calculator when you type this in. So when I'm in degree mode, I get an answer of 32,616 feet. Okay? Now here's the sticking point of the situation. This problem asks for miles. Uh-oh, we now need to convert our feet into miles. So a little known fact is the fact that there are actually 5,280 feet inside a mile. So what I'm going to do is I'm going to divide this by 5,280 in order to convert this into a mile answer. And so that gets me 6.2 miles. Okay? If this were on a test, I would give you that conversion just to help you out. Here is your very last problem. You're probably going to model it just off of mine, so please make sure you create your diagram. Take a moment to pause and do this problem. All right, so the answer you should have gotten is an answer of 6.2 kilometers, okay? Because once again, if you create your horizontal lines, the angle of depression was this guy right here, 26 degrees, which can also go right here inside of your triangle. And if you are looking for the length that you are going to, the horizontal distance would be this location right here. And you know the altitude, which is the height of the triangle, that guy goes right here. Okay? So once again, tangent is a strong presence in this section. All right, we are officially done with learning content of Chapter 8, but please know it does take a lot of practice. So make sure you're taking the time now to get ready for Tuesday's test. Have a great day.